find this Professor Chen, and now I want to give you a 5-minute head up for chapter 8, which is a very short chapters. We call the combined loading. These chapters, the whole purpose is to exercise what you have learned about the 4 types of the loading. Let me make one example here. Imagine we have a bar, something like this. Okay, so this basically is an L shape. And for example, if this is the clamped on one end to the wall here, and in this simple model, let me say if here we have the loadings, and the loading situation can be, for example, like this. At this point, we have a point loading pushing upward. Let me call this is called the F1, called the F. And for this example here, then and then let me put in the axial directions. We have another loading, and let me call it P here. So under the 2 simple situations, for example, if you're interested in finding what is the loading conditions, let me pick up a particular cross section here. So that is a particular cross section we're interested in here. Then let me draw the free bar diagram of that cross sections, and let me enlarge. So that's the cross sections, and then this is a portion, the other portion, and this is clamped against the wall here. Okay, so for this case, we can use the statics to first calculate the reactions on the particular cross sections, and quickly you should be able to find they should have the reaction which is equal to F, and also the point loading in this direction that is the normal to the cross section, that we call the P. And also this loading due to this force multiply with this distance here, and that we expect they will induce torsion here. Under these situations, then you can quickly identify we have such 3 types of the loading. So in terms of our learning, respect to this particular cross section here, the P is the axial loading. And that is what we have learned in chapter 2. And F is transverse loading. And that is what we learned in chapter 6. And T is the torsion. And that is our topic we learned in chapter 3. So under these situations, we might be able to tabulate the loading situations, and then individually, we calculate corresponding stress. For example, here we have the axial loading. So axial loading from chapter 2, we know that the induced normal stress is P divided by whatever the cross-sectional area A here. So here is we have the cross-sectional area A. And let me call that is A. And we know for the normal loading, there's a notion stress, so equal to 0. So the contribution is taken care of by this one. Now for the transverse loading, and from chapter 6, we know transverse loading induces no normal stress. And for shear stress, we know that tau equal to VQ over IT. So here you can individually determine what is the VQ, I, and T for these cross sections, and at any particular point. So we're taking care of this one. For the torsions, and that's T, in chapter 3, we know the torsion induces nothing in normal directions, but the shear stress is T, is TC or T rho over J. And again, the rho depends on the locations. And here, this is a rectangular cross section. Usually, this one applied to the circular cross section here. Okay, so furthermore, for other example, if you would have any bond bending like the reactions, then again the normal stress induced by bending is my over I, and with certain sign to indicate tension or negative to indicate compression, you can identify it individually for different problems. Again, corresponding to the bending moment, we expect no shear stress. So basically, by summing the four terms together, then you can get the distribution of the normal stress and shear stress around any point in this cross section. So again, in these chapters, you're going to exercise a few examples to exercise for this process. Thank you.